Hey guys, in this video I just want to run through the basics again just so that you can kind of tell the difference between the trig ratios that we talked about. And you've got yourself a right triangle. Doesn't matter what the angles are as long as it's a right triangle. And let's just focus our attention on angle A at the moment. So in the other video and earlier in class we talked about the tangent ratio. And the tangent ratio we talked about being the leg opposite divided by the leg adjacent. So first thing you probably want to do anytime you get these problems, if you're still mixing things up, is just label the picture. So label which angle you're working with, label which leg is opposite, right? This is the leg that's across, so that's the leg that's opposite. The other leg, of course, would have to be the leg adjacent, and adjacent means that it's just basically next to the angle. And the side up here, obviously, that's the hypotenuse. So take a second and label it until eventually you get comfortable enough that you don't need to. Alright, so if I'm using angle A as my sort of like my reference angle, then opposite would be here, adjacent would be here, and of course the hypotenuse, no matter what, is always across from the 90-degree angle. So we talked about the tangent ratio for angle A. The tangent of angle A is the leg opposite divided by the leg adjacent. Okay? That was tangent. Then yesterday we introduced two other ratios. When we did our tangent activity in class, we kept focusing on just the ratio of those two sides. But we just as easily could have done the same exact experiment using the hypotenuse. I'm sure you were wondering how come we keep, avoiding the hypotenuse. Well, it's not that we're avoiding it, it's we were just doing one thing at a time. So the next ratio we said was the sine ratio. I know it looks like sin, but technically that's the sine ratio. Okay, so this is tangent, this is sine. Sine of angle A, we said, was the... Oh, hang on, my cat's in the way here. Hang on, Skittles. Oh, no, that's Starburst here. Say hi, Starburst. Okay, let's try that again. Sine of angle A, we said, was the leg opposite, just like before, but this time, instead of dividing by the adjacent leg, we divide by the hypotenuse. Okay, these are just special names for those ratios. Those ratios exist no matter what you want to call them, but these are the names that we use to actually to reference them. So the sine of angle A is the leg opposite to angle A, of course, over the hypotenuse. And then there was one more called the cosine. Cosine is the name. Abbreviation is just COS, but that's cosine, equals the leg adjacent over the hypotenuse. So you see there are three different ratios, right? But they're set up using the specific trigonometric ratio that goes with them. So you have tangent, sine, cosine. Okay, so let's actually, let's just practice setting that up, and so you can get used to which one's which. Okay, so hopefully you wrote that down. If not, pause it, write it down. It's also on your worksheet. This was the worksheet you got, so there's the summary of sine and cosine. You have a similar worksheet that has the summary for tangent if you need to refer back to it, but it's all right here as well. Okay, so let's look at a picture. And the letters don't really matter. I'm just going to try to be consistent. There's my angle. Let's put some numbers in here. How about, I don't know. Let's go with 8, 15, and 17. How about something like that? And again, the numbers don't really matter. It's just a matter of making sure that it fits into the right triangle. So let's go ahead and try to find the sine, cosine, and tangent for angle A. Okay, we'll just do them one at a time. So we're going to need the sine of angle A, the cosine of angle A, and the tangent of angle A. And like I said before, I think it's a good idea, if you're still kind of getting used to this, is to label your picture. So I kind of drew the same picture just so you feel comfortable with it. But if this is the angle we want, then our opposite side, our opposite leg is the 8, our adjacent leg is the 15, and of course the hypotenuse is the side across from the right angle. So sine. Alright, if you remember from the notes a minute ago, sine was opposite over hypotenuse. Opposite over hypotenuse. So opposite is 8. Hypotenuse is 17, and that's pretty much most of the credit for that problem. Okay, sometimes it'll say to find, you know, an approximate answer and round to 4 decimal places. All right, no big deal. Just put that in the calculator. And let's see. All right, so I need 8 divided by 17. This is so exciting. I'm sure you're sitting at the edge of your seat wondering what this decimal is going to be. 470, and then I'll round it to 6. Okay, but that's all it's actually asking you to do in the beginning. The beginning is just setting it up. How do you set it up? Well, you follow the ratio that we talked about, the ratios that we talked about. Cosine. Cosine is adjacent over hypotenuse. And if that could have been simplified, we would have simplified it first, but there's nothing we can do to it, so we'll just put it in the calculator. And 15 divided by 17. 0.882, let's go with 4. Okay, because we can round it up. Amazing. Tangent. Opposite divided by adjacent. That's the one we've done a lot. And now we'll just do, oops, 8 divided by 15. Done. And that's pretty much how you set them up. Just to see if you're paying attention, though, let's try to do the exact same thing we just did, but let's do it with angle B. Okay, so let's go sine of B, cosine of B, and tangent of B, and see if we can figure it out. Now it's going to look a little funny because the way I labeled it was based off of A. So for the moment, I'm going to actually cross off what I labeled for A. I'm not going to cross off the hypotenuse because that's not going to change. It doesn't matter which angle we're using to get the hypotenuse. But now if I'm using angle B, the 15 is actually the opposite to angle B. And the adjacent to angle B is the 8. So if it helps you, do that each time. Either cross off or erase. I used pen, so I couldn't erase it. But either erase it or even redraw it. Okay, and let's just basically start the problem over using angle B instead. Sine of angle B is opposite divided by hypotenuse. So that would be 15 over 17. Oh, wait a second. I have that number already. That was up here. That was the cosine of angle A. Well, since I switched my opposite and adjacent, I would expect my sine and cosine to basically switch as well. So my sine of B is the same as the cosine of A, so I already have that. 15 over 17. And if you remember those little patterns, then please use them. Cosine of B, well, if sine of B was the cosine of A, well then cosine of B I would expect to be the sine of A. Let's double check. Cosine of B is adjacent, which is 8, divided by hypotenuse, which is 17. We got it. That's right here. And then the tangent, we did a little trick as well. I don't know if you remember, but the tangent of A, if it was the 8 over 15, which was opposite over adjacent for A, well, B just says, okay, instead of doing the 8 over 15, we're going to have to do the 15 over 8. It was the reciprocal. We talked about that in class too. So that's 15 over 8. That number I do not have yet, so I will calculate that out. And let's see, 15 divided by 8, and that's 1.875. And you just found the sine and cosine of the acute angles of a right triangle. That's the basic idea. Okay. In the next video, I'll do some examples out where you have to do the solve for x type of stuff, and hopefully this helps you get started. And let me know if you have any questions. See ya.